Hello viewers, in today's class we are going to discuss one important and conceptual problem from differentiability of functions, right? And here we are going to solve one multiple choice question which goes like this, right? So here we are given this problem, that is the function f of x, which is equal to sine inverse cosine x, is not differentiable at, and here we are given four options, right? And we have to see at which points this function is not differentiable, right? So let us start. So we have earlier seen that a function, say y is equal to f of x, is said to be differentiable if the right hand derivative and the left hand derivative both exist at some point, say x is equal to a, and they both are equal, right? So a function is said to be differentiable if the right hand derivative and the left hand derivative both exist at some point, at some given point, and both are equal, right? So in this case what we will do, we have to find the values of x for which this function is not differentiable, right? So let us first find out the derivative of this function f of x, right? So here we are not going to use the concept of right hand derivative and the left hand derivative. Rather we'll straight away find out the derivative with respect to x, and then by applying some algebraic manipulations we can see the points at which this function is not differentiable. So the derivative, that is f prime of x, is equal to d by dx of sine inverse, and here we have cos x, right? So we have to find the derivative of sine inverse cos x with respect to x. Now see, we know that the derivative of sine inverse x with respect to x is 1 over square root of 1 minus x square. So this is the standard result in differential calculus, right? So here for x we have cos x. So what we will do, we'll write 1 over square root of 1 minus cos square x, and then by chain rule we'll find the derivative of cos x with respect to x, right? So now the derivative of cos x is minus sin x, so we have minus sin x divided by square root of 1 minus cos square x, right? So the derivative of fx is equal to minus sin x divided by square root of 1 minus cos square x. Now we can use here the concept of absolute value function, right? Now let us concentrate on this term which is in the denominator, right? Here we have a square root of 1 minus cos square x. Now see, from the theory of functions we know that mod of x is defined as a square root of x square, right? Now see, here we have minus sin x, and we have square root of 1 minus cos square x. So from trigonometry, 1 minus cos square x is equal to sine square x. So here we have a square root of sine square x, right? And this is the definition of mod of x, which is equal to square root of x square, right? So now square root of sine square x may be replaced by mod of sine x, right? So the derivative f prime of x, the derivative f prime of x can be written as minus sine x divided by mod of sine x, right? So now from this expression we are able to find out the values of x for which this function f of x is not differentiable at the particular values of x. So now we know that if we have a function, say h of x, which is equal to mod of say g of x, then this function h of x is not differentiable at those points for which g of x is equal to 0, right? So here we have f prime of x is equal to minus sine x over mod of sine x, right? So now this function f of x is not differentiable at those points for which the quantity which is inside the mod symbol is equal to 0, right? So for sine x is equal to 0, this function f of x is not differentiable, right? So f prime of x is equal to minus sine x divided by mod of sine x, right? And from theory of functions, we know that mod of gx is not differentiable for those values of x for which this quantity, that is gx, is equal to 0. And here inside the mod function symbol we have sine x, right? So for sine x is equal to 0, this function f of x is not differentiable. So now we have sine x is equal to 0, and this is a trigonometric equation, right? And we know that the solution of sine x is equal to 0 is equal to x is equal to n pi, right? So whenever this angle x is an integral multiple of pi, where n belongs to the set of integers, then sine of x is equal to 0, right? So x is equal to n pi is the solution of this equation, that is sine x is equal to 0. So here n is equal to 0, plus minus 1, plus minus 2, and so on, right? Now if we look at our options, we can see that when n is equal to 1, then we have x is equal to pi, right? So here we have this option, that is option A, right? Okay, when n is minus 2, then we have x is equal to minus 2 pi, right? So we have this option B as the correct option, right? And when we have x is equal to plus 2, then we have x is equal to plus 2 pi, which is our option C, right? So in this problem, the function f of x, which is equal to sine inverse cos x, is not differentiable at these 3 points, that is x is equal to pi, x is equal to minus 2 pi, and x is equal to 2 pi. So here these 3 options are correct, that is option A, B, and C.